name is Sept, and I'm responsible for customer engineering for Google Cloud Security products. Today, I want to talk to you about some of the innovation we're doing with Chronicle. In this demo, I want to go through an example of how you can detect modern threats. I'll start with showing you a very innocent-looking document on the surface. Now, what's happening behind the scenes is this is not so innocent. This is detected as Emotet, and it's part of a recent revival of a campaign that's been wreaking havoc on companies all summer. If the user clicks on Enable Editing, they wouldn't see anything, but under the hood, this will use a macro and it will launch a PowerShell, which will connect to a malicious server and then do a number of other bad things. Now, while this is all fun to explore, there are a couple of reasons why even after spending millions of dollars, defenders still have a hard time with these types of attacks. The biggest reason is only having partial visibility. If I'm a defender, even if I know my adversary well, which by the way I don't have time to do, I just don't have the data. Endpoint data is being thrown away, NDR data is being thrown away, cloud and SaaS data are intermittently being thrown away, things like DNS, email are not stored for a very long time, usually, you name it. I could have indicators of any bad thing in the world and it still wouldn't do me much good because I don't have the data to find it in. The second reason why detecting these types of modern attacks is hard is because searches are slow and the detections we do today are really very predictable to actors. Even if you have all the data, your searches and detections, they may take minutes or even hours. And at that point, you're not at an advantage. If a Google search took me that long, I'll just give up on searching things, and then my knowledge of the world would be limited. We believe that faster searches lead to productive and happier teams, but they also lead to this pattern recognition, this knowledge building that can very quickly lead to better automations, better detections, better learning. And these types of things are very difficult for an actor to avoid. This is the guiding principle and vision behind Chronicle and behind the work we're doing with Chronicle Detect. Frameworks such as MITRE ATT&CK, for example, give us really great maps of all the known ways that actors have been seen operating in the wild. And they reduce an infinite problem to a smaller, more finite set. Now you might think, wow, okay, these are 176 boxes, and maybe all I need to do is just check those boxes and everything will be good. And yes, in some sense that is true, but in reality, doing MITRE ATT&CK at scale is really, really hard for almost each and every individual one of these boxes. In that example, you saw in action some of the main techniques highlighted here, that are simple but yet really, really hard to catch. Now let's switch over to Chronicle. When I log in, I see a petabyte plus of data, and this should really become the new normal. This should really be the standard for professionals to look at that amount of data. And not only that, but we think searches should be super fast in that type of system. Now, let me put in that domain we saw in our Emotet, that bad command and control server that we just saw. You can see that I can immediately get a story. What happened? What's the timeline? Who saw it? Who didn't see it? Who accessed it? I'm not chasing down a random 10.0. whatever IP address. I'm not staring through a grid of stuff. Data should make timelines and stories with who and what and how. You don't really look at Facebook and you're like, oh my god, how cute, user with IP 1234 is now married to user with IP 1235. Let me go and query the users table to see who they are. Then let me go and query the comments table to figure out what others have to say about this. Like in the real world, this is ridiculous, and yet that's kind of the standard we have in security today. Okay, well, searching is great, and semantic understanding of the data within timelines is really groundbreaking once you really get used to it. But let's be real, you wouldn't have time to find every single bad indicator out there. You need a more scalable detection technology. Let's take a look at some of those here. A very important design principle we have is what we call retroactive evaluation. If you look here, we evaluate bad stuff thrown at the system both forward-looking, which is easy, as well as back in time, which nobody really does. It's easy for an attacker to change something forward in time. Something gets published in a feed, I just change my IPs and domains. but they can turn back time and unuse what they already used. Okay, now let's take a look at our first MITRE attack technique that we saw, that spear phishing attachment, that attachment email. It is something you cannot block. You can't block emails, you can't block attachments or anything like that. You need to get more surgical, more specific. It's extremely common to have to trust security solutions such as your email gateway or email provider or your AV or your proxy to catch this type of stuff. In fact, think about it. What else could you really use, right? Especially if you didn't have visibility across all the data. Now, while a bad attack can be hiding behind any of these alerts, the problem is when you pop out the alerts, it might just be mumbo jumbo, you know? Something somewhere seemed odd. The email, there's an email sender, there's a recipient, there's a subject. This might be good, might be bad. It might need some investigating. I might start following a trail here and find out what happened. But in a slow system with partial visibility, that becomes nightmare. This email might be bad and yet nothing may have happened. The user didn't click on it. They didn't enable editing. That's all things you have to find out. To add more to this problem, it's not like security was a walk in the park before, but with the pandemic that has been going on, this has created a unique challenge for defenders. Nobody's really on the network anymore for most enterprises. Visibility is really, really hard. In this example, this means that I get an email alert that will give me the IP address of the user's ISP somewhere, and you can't really do much with that. Well, with Chronicle, we did some really smart things. We fused the data together, even data that has different identifier, like a Windows SID or a username or an email. And we sort out through things like Active Directory dumps and Azure AD and DHCP, and we do that with zero work from the side of the customer. Because of that, I'm able to see a VPN login that has my username, next to an email log that doesn't, next to a proxy log that does. And I can also see a few other things that could really make for a powerful detection. Now, let's look at a device in this example. I'm going to zone in on the device that this happened, where I opened my email message. But now I have a full timeline, and I have even full Tanium streaming telemetry from the endpoint directly to the cloud with no data being hogged by the network, and this is showing a full picture. And Chronicle will also call out things that we consider weird, like this domain is low prevalence. That means it's rare. Powerful indicator to use for detection. This domain is also new to the enterprise. That's also interesting. There's a file detected through one of our partners. Also interesting. Not to mention this PowerShell here is really something you should not be getting used to seeing. This probably gives you the idea that it's not so hard to see patterns of weird or patterns of bad. And with Chronicle, we paid incredible attention to detail in showing you data in which these types of things become obvious within a timeline. We could have easily just built a boring grid, but we wanted to really bring this fourth dimension, so we spent the extra time to do that. And for a simple reason, what is obvious to human eyes can be taught to machines. That's what Chronicle Detect is all about. Bringing scale so that you can express things in detection that you couldn't express before. Now, let me look at some of the detections that we have and see how they kind of correspond to some of the MITRE attack categories and techniques we saw. This first detection is a typical rule you will find in almost any company. Chronicle Detect will support these types of legacy rules, but can do a lot more. It will allow you to enrich that detection with other data points. You can filter it down instead of having your people do that. Now let's take a look at the second detection. The second detection focuses on another technique we saw in attack, execution via PowerShell. It's a bit less noisy and more sophisticated, and probably something you've seen before. While this looks like a simple correlation with some time windowing, with PowerShell being launched by Microsoft Office and then making a network connection, remember, we're talking about streaming EDR telemetry. You can't put these things in memory. You can't search them through a couple of machines. You can't query them through a couple of machines. You need hundreds, if not thousands of machines. And one thing we do here is we distribute this query on many, many machines that get spun up instantly by the Google infrastructure. We use things like switches that optimize queries, optimize joins, and optimize how the data is being sent. We rely on a network that can throw all this kind of volume of data between the different nodes. And then that results in the fact that this query can execute through a vast amount of data super quickly. There's many things Google isn't good at, but one thing that we really shine in is that type of problem. So that means that I can do this correlation. 72 hours of data is searched with correlating over events that may have spanned days or hours or minutes, it doesn't matter, and returns in a few seconds. It's nuts, but it can do that. Now let's look at the third class of detection, something I like to call data-driven detection. This is something that can catch a lot more variances and a lot richer variations of the different attack techniques, which can change every day, by the way, though the different methods can change all the time. Here's where things like anomalies or prevalence come to play. Attackers often use very common tools and they just kind of use them in a little bit of a weird way. One of my all-time favorite detection is looking at obviously PowerShell events, but PowerShell events connecting to a rare domain. Now, that's just one simple example you can do, but think of all the things you can do. Rare hash talking to rare domain, rare host receiving very high amount of data. Of course, if you have infinite money, you have talented engineers who can build a mini Google, that can theoretically work, but in reality, we don't see people run these types of detections. We see a lot of our customers wanting to do that, and this is why we built Detect. Companies, unfortunately, are stuck in a world of alert whack-a-mole because the tech can't even ingest, let alone make sense of the data. And any detection that is remotely interesting takes a really, really long time to run, and it becomes really intensive and really complex very fast. Chronicle is not just a cheaper, faster way to detect, analyze, and investigate the things you're used to. Yes, it will make you more effective than that, but more importantly, it will help you expand on that into the world of petabytes and into the world of infinite compute. Thanks for watching and happy hunting.